Hi, my name is Brady Palomares, and today we're going to be discussing centrifugal force in circular motion. And we're going to do a demo.
We're going to discuss some of the fake forces in physics that tend to confuse people. Let's get started. Imagine you're sitting in the car traveling in a straight line path, and the car suddenly makes a sharp left turn. You feel as though there's some kind of force pushing your body to the right into the side of the car. However, this is not the case. The only force acting on your body is the force of static friction between you and the seat. So, if this force acting on you to the right is not real, what is this? We could call this a centrifugal force or a fictitious force. The reason we feel that our body is being pushed to the right is because of our inertia. Our body wants to continue traveling in the original straight line path, and that's the reason for this experience. With this knowledge, let's consider our demo. If there's no force acting outward on the coin, what is the reason that the coin slips as we speed up the turntable? Let's draw the forces on the coin, and Newton will help us figure this out. We have a normal force or contact force acting upward on the coin, the weight of the coin acting downward, and the centripetal force, which is the force of static friction acting radially inward. Let's write out some equations using Newton's second law, force is equal to mass times acceleration, to further analyze this. Looking at the force in the x direction, we have the force of static friction is equal to the centripetal force, which is mass, times the centripetal acceleration, which is velocity squared over the radius of the circular path. Looking at the forces in the y direction, we have the normal force is equal to the weight, due to the fact that acceleration in the y direction is equal to 0. Substituting in for the force of static friction, this is equal to the coefficient of static friction of the turntable times the normal force. So plugging in our values, we can see that our final equation for the force in the x direction is this. Now we can see something interesting. The mass of the coin cancels in this equation. So if the mass of the coin doesn't matter, what's the reason that the coin slips? Let's consider something else. What about the velocity? If we solve this equation for the velocity, we can see that this is equal to the square root of the coefficient of static friction times acceleration due to gravity times the radius of the circular path. What velocity is this? This is maximum velocity. When the coin exceeds this maximum velocity, the force of static friction is no longer strong enough to hold the coin stationary. That's the reason that the coin begins to slip as we speed up the turntable. I hope this helped clarify some of the common physics misconceptions that people believe are true.